Now, so far up to this point, in all of our previous examples, we've been throwing print statements whenever we didn't want a certain behavior. Now, this doesn't actually stop the program, but it just throws the print. If we want to throw a message and stop the program due to some certain behavior, then we can raise what is called an exception. And this brings in the topic of exception handling. So, the simplest syntax looks like this. I can say raise exception, and then I put my message inside, invalid action. If I run it, right away you can see how I'm getting this exception message, exception invalid action. This was the exception and this was the message. This raise keyword followed by the instance of the exception class with the input being the message you want is how Python under the hood throws exceptions and halts programs. In fact, Python has its own exception hierarchy shown as follows. We start with base exception and then we trickle down to all the various exceptions that we see. Some of the popular ones being import error, OS error for your operating system error. You can have runtime error to control any runtime issues. You can have not implemented error if a part of a code is not currently implemented. You can have system error if, say, the system can't handle that. You can have type error if the object type that you specify is incorrect. Value error if the value you specify is incorrect. And there's many more. Now, I'm sure there are like functional differences between each of these exception subclasses. I, for one, am not aware of those differences in functionality. I don't really dive too much into that. What I typically do is I just use the different exceptions by their names and simply input the message I want. That way, I can give the user a clear distinction on what type of error they're getting. For example, if the user runs into a scenario where they've specified an invalid type, I can say raise type error invalid type. Okay? Or if, say, there was an error where the server crashed, I can raise a system error and say server crashed. Now, I can even extend the exception hierarchy and create some of my own personal exceptions. And the way that this would work is how it works with any classes. You can create a child class, say class server error of system error pass, and now I can raise the same error, but now I can say server error instead. So it's more precise on what the error is a server error. Now, there's more to handling exceptions than simply just throwing or raising those exceptions. We can also control how exceptions are thrown. For example, let's say we were to create a divide function, def divide, where x is the numerator and y is the denominator. If the denominator is 0, then we can raise an exception. Cannot divide by 0. Okay? Else, we return the result. So this is how we can control throwing an exception by using an if-else statement. So now if I try doing divide 7 by 0, I get this message. Luckily, Python already has an exception built in for this. If I were to simply just do 7 by 0, I get 0 division error, and then division by 0 message. So this is built in for Python already. But what if we want to do something else other than throw a 0 division error? What if we want to ignore the exception and give an answer of 0? Then this is called catching an exception, and we can achieve this by using the try and except block. So if we take our same function, let me take it, put it down here, I can now replace the if statement with a try block. So I'm going to put that up here, try. I'm going to try returning x divided by 0, but in the case that I raise the exception, 0 division error, I'm going to catch that exception using the except keyword. Okay? Now, except by default will catch any exception, but if you want to catch a very specific exception, you can specify the exception. So 0 division error. And then in that scenario, we want to return a 0. So now, if I try doing print division 7, oh sorry, not division, divide 7, 0, I get 0. Now this try except structure is very powerful. There's actually more to it. We can even look for multiple exceptions in an order and then do stuff on top. Take this for example. In this we are trying the statement in the try block, but first we are looking for a type error. If the type error is caught, we are executing this statement, whatever is underneath this block. And then if type error is not caught, we are then looking for a value error, okay? And then this block is executed. If both type error and value error are not caught, then we are looking for server error and executing this statement, and so on and so forth. And if neither are caught, then we can specify an else. What else will do is it will execute a statement if none of these exceptions are caught. And then you will have a finally block which will execute code anyways, regardless of which scenario you hit. Okay? So let's see a use case of this. So I've done two things. First, I've created my own exception, len error, which extends exception. And I call it len error because it will return an error whenever we have the wrong length of our item. And then I create a class called color. Inside a color, I take its RGBA components. RGBA is 3 components, so the length of component has to be 3. If it's not 3, I throw a len error with a message, please enter 3 components. And then I go through each component. I check if the component is an integer or a float. If they're not, then I raise a type error. These must be integers or float. Lastly, if these two conditions are met, I check if the component values are within 0 and 1, or else I get a value error. Components must be within 0 or 1. And then, once that's all satisfied, then I set the components. Okay? So let me run this. To verify this whole procedure, I've created a function, def handle creating colors of the components, where in the try block, I create an instance of color with the components I want to input. If I have more than or less than 3 components, basically if I don't have 3 components, the except block should catch a len error, which should be reached first. You're supposed to enter 3 components. If that was fine and dandy, then I will check if I reached a type error after that. So I look to catch a type error. You're supposed to enter ints or floats. And lastly, I look to catch a value error because that is checked last. You're supposed to enter values. So the order of this is important. As the order of this is coming up, I want the order of this to reflect this. And if all of this is done successfully, then else I print color successfully created. And finally, I will return the result anyways. I will return C. So I will go ahead and try each case. I will say case 1, handle creating color. I don't have 3 components, I have 2. So this should catch a len error. And indeed it does. You were supposed to enter 3 components. Notice how I'm getting returning result anyways because the finally block always runs. And I'm getting none because C by default was none. Now let's try case 2. Case 2, I should look to catch a type error because 2 of these are integers, but one of them is a string. You were supposed to enter ints or floats, so I got this message. Again, the finally will print anyways, and I get none. Next, let's try case 3. So this is case 3. All of these are integers or floats, but one of them is greater than 1, 1.2. So this shall now catch a value error. Let's run it. And indeed, I get that. Again with the finally statement. And last but not least, let's try case 4, where our color is fully correct. So we have 3 values, they're all floats or integers, and they're within 0 and 1. So this should throw color successfully created because we finally reached the else block. And again, the finally block. And now, since C was successfully created, I'm returning that C. So I'm returning the object, main color object, okay? So with this example, I hope you're finally able to understand how the structure of a complete try block is working with try, except, else, and finally. Now, you may be wondering for a moment, what really is the purpose of the finally block? Couldn't we just skip it and put the print statement outside of the whole try block and our code should run the same? Well, not quite exactly. The finally block does have a purpose. It actually allows the user to specify what to run under any exception thrown in any of the blocks above it, not just the try block. For example, if I create an invalid color in the else block, finally will still run. If I were to say C equals color, and then say 0.1, 0.2, just this. So I'm gonna get a len error. Finally will still catch this. So if I run it, I'm gonna rerun this. And now I'm gonna go all the way down to case 4, where it will go to the else block. This will still run. If I were to take the finally block out, so let me comment this out, and rerun this, now this will throw an error. Because there's no finally block to catch any other exception that's thrown inside these blocks. So that is the power of having finally. So that's a brief overview on exception handling, how you can throw an exception and catch an exception, and to use the complete try, except, else, finally structure to handle what you want to do with your exceptions. Okay, cool.